Good evening, everyone. I'm Likita Reddy, Assistant Professor in the Department of Information Technology at Reddy College of Engineering and Technology. I'm delighted to be your host for this evening. It is my privilege to extend a warm welcome to all of you to the fourth day of AICTE-sponsored 6-day Atal Faculty Development Program on Next-Gen Solutions for Medical Challenges powered by AI-based intelligent systems organized by Department of Information Technology at MRCET. Without further delay, let's start today's session. It is delighted to introduce our esteemed speaker for this session, Mr. Chenna Reddy sir. He has 10 plus years of experience in building ETL solutions and worked on various areas like Snowflake, dbt, Azure Data Factory, Azure Databricks, Azure Synapse Analytics, AWS, Python, Oracle Integrator, SQL, and Unix. Currently, he is working as a lead data engineer in Cloud System Integrated Incorporated Business, New Jersey, United States of America. Today, we have the privilege of being in the presence of a valuable resource professional in the field of IT. Dear all, please join me in welcoming Mr. Chenna Reddy sir. Welcome, sir.
Thank you, ma'am. Thank you for introducing me. Hello, all. Good morning. Good evening. Yeah. Shall we start, madam?
Yes, sir. Please start, sir. Yes.
Yeah. Let me share my screen. Are you able to see my screen?
Yes, sir. It is visible, sir.
Yeah.
Okay. Yeah. So thank you for introducing me, madam. Thank you for making me a part of this wonderful training. I'm really privileged to have having me here. Yeah. So today's agenda is I'm going to talk about the predictive analytics in healthcare. I have vast experience in the healthcare domain. I worked in Anthem Healthcare almost for 5 years. So we have processed a lot of data, and we have worked on different machine learning algorithms and data science applications. So I'm going to discuss about the all the applications related to the healthcare domain, how the predictive analytics is impacted actually the healthcare domain, and following by the article discussion, I'll take one use case around it, the predictive analytics use case. And I'll show you practically how a machine learning algorithm can be implemented in real time, and how we can predict it in a real-time manner. So that is today's agenda. Yeah. Okay. So what if you could know about our disease, or I could say illness, before they can happen, I would say. So what I meant to say here is, without your consent, if you're okay, if you know that in next year, or maybe in next 3 years, you may get diabetes, or BP or heart attack. If you are able to if you come to know the disease or the illness upfront, then you will take the precautionary measures before at least some precautionary measures before they happen. And how this is going to help to the doctors, giving the suggestions or helping the patients to take care of their health. Okay. So all these are possible with the help of artificial intelligence. So today's topic is, even though I call it as a predictive analytics, it is not a separate topic. It is one of the branch in artificial intelligence. So you might have heard many terms like neural networks, deep learning, generative AI is there, machine learning algorithms are there. So all these things are the part of the I can say artificial intelligence. So, but particularly we are going to focus on the predictive analytics today. So what exactly mean by this, the predictive analytics? So we'll give historical data as an input to the machine learning algorithms in artificial intelligence, and we'll try to like predict something out of it, which we don't know, which we are going to like expecting in future. That's what like predictive analytics is. Okay, so before we deep dive into the predictive analytics, I wanted to let you know what are all the different classifications are there in the like predictive analytics. The main classifications are supervised learning, like unsupervised learning, semi-supervised learning, and the reinforcement learning. The name itself indicating that supervised learning. Supervised means somebody has to be there to train the data. Predictive analytics is nothing but giving the historical data, train the data, get the results out of it, and like pass on the test data and get the predictions out of it. That's what the meaning of that one. So supervising means who has to supervise that data, who has to train that data. So we are supposed to like just a second. Okay, sorry. Yeah. So somebody has to train the data. So who is going to train that data? So being a like like data scientist has to do that one actually. So the meaning of that one is supervised learning is, let's consider for an instance, you consider computer is like a student, and you are the teacher for that one, and you give examples with an answer to the computer, I can say. So examples in the sense, examples we have to give in the form of data here, and answers in the nothing but the prediction, whatever you're predicting, that you have to upfront, you have to give it, and you have to train the data based on that one, based on that labels and the data. We call it as the labels actually here, the predictive outcomes in real time, I can say. Okay, so like we have to like predict some output out of it. So here, the best example for this one is, you can show like you can train the machine learning algorithm or model or computer by showing the pictures of the dog or pictures of the cat or pictures of the apple or whatever it is actually, in different angles or different directions. You show that picture and train it actually and make it understandable, and whenever you show the new picture to it, it will understand, it can able to identify that picture. That is what we call it as a supervised learning here. That means you are training it and you are like predicting a expected output out of it. So that is what we call it as a supervised learning. Most of the cases in real time in the industry point, standpoint, I would say we use like supervised learning only, because we train the data, because we know, we have better understanding of the data. We know what outcomes we'll get. We know what measures we are going to get it for this year, for the next year. So based on that, we train the data to the algorithms. We use the algorithms, we train it, and we predict the outcomes out of it. And the second one is unsupervised algorithm. So unsupervised is nothing but like nobody is going to train it. Then how does it understand? Like your system or machine can understand it. I would say that no teacher is there to train it. The computer itself has to explore, and it has to find out the patterns out of the data, that whatever we are inputting here, and it has to where we don't give any labels here, or we don't give any specific patterns here. It has to identify that pattern and it has to predict something out of it. So that's what we call it as a unsupervised learning, I can say. So I'll give like some examples also out of it down the line. And the next one is semi-supervised learning. I can see it's a hybrid one. It's a mix of supervised learning and the unsupervised learning. Why I'm calling it as a semi-supervised here is, we don't give completely unstructured data or unpredictable data, and we are not asking computer to predict on your own. We give some hints to the computer. Hey, if you get this kind of data, then predict like this. We give some hints, and only few hints I can say. I can say 20% of the hint we give, and 80% will leave it to the system or machine to predict out of it. That's what we call it as a semi supervised learning. And last one is reinforcement learning. We don't use generally in the industry standpoint, I can say this reinforcement learning, but still we have to understand about this one. Many applications are getting developed recently based on this reinforcement learning as well. So what exactly mean by this one is, let's consider you're training you're giving a training to a dog. So like you're asking every time you're asking dog to sit. Okay, whenever you give an instruction, you're asking dog to sit. So whenever it sits, you're giving like a reward to that one. And when it is not, when you pass a command, when you pass a instruction to it, and if it is not sitting, you don't give any reward to that one, I can say. So I can say it is completely trial and error basis. We don't train it, the model. We don't train the system. We don't train the model, I can say. So system has to train on itself on trial and error basis. Trial and error basis means once it get the error, it has to correct automatically by itself, I can say. So that is what we call it as a reinforcement. The best example for this one is self-driving cars in USA. Recently in USA, some of the companies, even not some of the companies, Tesla has launched a beautiful car called driverless car. People started using it actually here. So you don't need to have any driver here. You just need to book that particular car in the Lyft app or Uber app. Here also we have like Uber app. So you just need to book that one, and car will come within a specific time in front of you, and you have to set up the destination. Anyway, you're passing the destination details also there, and you just need to enter the you just need to click on start button inside the car, and it will start and it will take you to the destination. So that kind of applications can be built with the help of reinforcement learning, I can say. So can you guys confirm, am I going fast or is it okay?
Okay, sir.
Yeah, thank you. Okay. Under supervised learning, what are all the different machine learning algorithms we use regularly? Under unsupervised learning, what are all the different algorithms are there? I've listed all the mostly used algorithms. I mentioned only few here, not all here. Mostly used ones I mentioned, I can say. As I mentioned, we mostly used in the industry supervised learning only. Supervised learning, we use linear regression, which is mostly used one across the industry, I can say, and logistic regression, and as well as SVM, and as well as random forest. And we use for some of the applications, we also use the XGBoost as well. Okay, and for unsupervised learning, we use K-means algorithms and DBScan. Uh, of course, the TSNE is also there. Under semi-supervised learning, we use different combination of these two, I can say, supervised learning algorithms and as well as unsupervised learning algorithm. Both combination we'll try to use here. Under reinforcement learning, we use actually the policy gradients and the Q learning. Both we'll try to use mostly. Okay, moving on. Okay, so what are all the different applications related to this predictive analytics? Where exactly it is creating that impact in the industry, I can say. So I would say there is no industry in the market or in the world, I can say, without this artificial intelligence or without this predictive analytics. Every industry started adopting this one, and they started improvising their process, or they started improvising their revenue, at least I would say, at least. Okay, These are all the some of the industries I mentioned here. Like only few industries I mentioned here. Okay. Like some I'll like walk you through how they're like making an impact here and how like they're getting benefit out of it. Okay. The best one, the first one is marketing and sales. You guys know, like we have here like Walmart, and we have like a Costco, and we have like D-Mart, like we have different like supply chain like retail stores are there. So every year they wanted to predict actually how many sales will happen like in the next year. Based on that one, they wanted to invest in their business. Based on like that one, they wanted to give promotions to the customer. Based on that one, they wanted to like what I can say, improve their business. They are implementing everything in like I've done one project actually in the real time in the that's what we call it as martech. Martech is nothing but marketing technology. So what exactly we do here is we take the data, customer data, we analyze it completely, and from that we take out the premium customers or prime customers from my business. I'll offer some promotions to them, and I'll try to get attracted towards my business them, and I'll try to like make out of like, more business out of it, I can say. In that way, I'm using my artificial intelligence to improve my business and to improve my sales here. So that is the first like industry that is that has impacted the artificial intelligence has impacted. And the second one, which is my favorite one, which I'm working currently right now, finance and banking. How it is getting impact, how AI is making like a difference, or AI is impacting that industry is previously, I mean, previously means like before this artificial intelligence, if there were any fraudulent transactions were happening in the bank, we were not come to know whether it is a real transaction or fraudulent transaction. And now, within a second or within a like a fraction of seconds, we are coming to like we are getting to know whether it is a real transaction or like fraudulent transaction. Recently also, I've done $1,000 transaction for like I purchased like a like Apple iPhone, and Apple iPhone, sorry guys, yeah. Apple iPhone, I purchased thousand, I made like $1,000 like dollars transaction, which I did not I have never done that like transaction before, because I used to do only $100, $120, max $500 only. But all of the sudden, whenever like $1,000 deducted from my credit card, bank immediately sent me a message saying that, hey, like $1,000 got deducted from your account. Is it a real transaction or not? If it is a real transaction, you reply back to this like message, then only we will approve this transaction. Otherwise, we'll like mark it as a like suspensional kind of thing, or fraudulent transaction, and we'll decline the transaction. Then immediately I clicked on yes, like the transaction is made by you or not. Click yes or no. Like they'll send an SMS. We have to reply back to the saying yes there. Then only they'll approve the transactions. So here, what they're trying to doing here is they'll try to identify the patterns from your credit card. Patterns means they identified the pattern here. Okay, I have now done the less than $1,000 like dollars transactions in my transactions ever before. So all of a sudden, if I do that one, they identified it as a fraudulent transaction. Like that, they can easily identify the fraudulent transactions in the banking and financing sector, especially. Even in my current project as well, even in my current client as well, we are processing this kind of data only. We take the data, transactional data from the bank for every second, for every minute. I can say we do have batch processing, we do have real-time analytics as well, and we take the data, we identify the like what I can say is like odd transactions out of it. Odd transactions in the sense we apply algorithms out of on top of it, on top of the transactions. We identify the odd transactions on it, and we we separate out the transactions and we send an SMS to the customer saying that, okay, this might be a fraudulent transaction and could you please approve it? Until they get approved, we don't process that record actually. So that is what we are doing here, like in the banking sector, I would say. So currently I'm working for like one of the topmost Japanese banking customer. So this type of data we process on daily basis. Okay. And the third one is healthcare. Anyway, I'm going to talk about like more about the healthcare applications here. I'll leave that one for now. And next one is manufacturing. So this one also, I have example as well on this one. I've taken Pfizer as an example for how Pfizer is managing their supply chain management using this like their production and all. Anyway, I'm going to discuss about that manufacturing related thing also. And the next one is retail and e-commerce. You guys know like Amazon is a big giant in USCR as well as in India as well. Flipkart as well, of course. So whenever you go on to whenever you go and like search for some product, let's say I wanted to purchase like mobile phone or laptop or something else in my just a second, please. Yeah, sorry. So whenever I like click on some of the products, right? So they start giving like recommendations to me. That also happening through artificial intelligence completely, I would say. So how it is happening is whenever you click on some product, we take the data and we process it separately through like real-time process. We call it as a Kafka processing, I would say, to process that kind of data. And whenever you open next time YouTube or Instagram or any other social networking websites, we start showing actually, hey, you clicked on so and so website, so and so product, and this is the offer is going on. This is the offer that is currently happening on the so and so product, and these are all the different items you have under this category, under mobile phones or under the laptop category. So you wanted to buy it or not, like that we give some predictions, we recommendations, I would say. So in that way also they're making business out of it. So retail and e-commerce companies, I would say. And the next one is supply chain and logistics. So even supply chain and logistic companies as well, if at all they wanted to like automate their process, they wanted to transport their products to the different countries or different locations. They also started using their artificial intelligence in their own domain, I would say. And the next one is energy and utilities. Of course, this one recently they started using. What exactly mean by this one is every year or every month they started taking up the data from the customers, how many units they can energy and utilities, power consumption, I would say, water consumption, I would say, water and energy consumption. Okay, so how much consumption happened during last week? How much consumption was happened during summer season? How much consumption was happened during the winter season? They'll do analysis on top of that one, and they predict next year by summer season or by winter season how much they can have, how much they can generate the electricity, how much they can have the water, how many liters of water they have to maintain in the tankers or in the like ponds. So they will try to predict or they will try to plan upfront based on the data that they are like processing here. In that way also, like so that it will not be a problem for the energy providers, I can say. Like a lot of energy provider private companies are there, so it will be just like a upfront what I would say is giving upfront, we are giving just a warning to them. Okay, so in summer season we may get these many number of units, we may get a load of these many number of units. You be prepared for that one. In that way, we will try to like give that information to them. And of course, insurance as well. So as I mentioned in financial and banking, similar to that one, even in the insurance also, if any fraudal insurance claims are happening, like we can predict it easily. Okay, so let's say so and so patient or so and so customer like continuously claiming the claims, or if he's all of the sudden is claiming like more amount, then we'll try to treat it as a fraudulent transactions, I would say. So I'm lucky to say that I was as I told, I worked with one of the healthcare company, that is Anthem, which is one of the topmost healthcare company in the USA. So we used to process this kind of data actually at the time when I was in India. So that is also one of the healthcare application, I would say. And public sector and government as well. Of course, they process the finance related data, and they'll try to predict the needs of the people out of it, and the sports and entertainment as well. And one example I wanted to give you here related to the sports and entertainment. Even sports also, like sports and entertainment like sector also started using like artificial intelligence in their domain. So not last soccer world cup, previous soccer world cup was happened. You know how France won the match? They completely like ran predictive analytics on the data of the players, and they placed correct players in the team, and because of that they won that World Cup. And once they won the World Cup, they announced this statement actually officially. So this was happened only because of the artificial intelligence that we ran in the background. So that is the impact of the artificial intelligence in the like entertainment or sports industry, I would say. Okay, and these are few like applications, I would say. There are so many applications are there in the market, like people started using, or market started using, or adopting this artificial intelligence, I would say. Okay, so far so good. Any questions? Are we good? Yeah, moving on. Okay, so since today's like agenda is to understand about the predictive analytics of in healthcare domain. So these are all the different applications in the healthcare domain, I can say. So overall, I would say, because of this artificial intelligence, because of this artificial intelligence in healthcare domain, they improved the patient's care, I would say. They improved the patient's outcomes, I would say. And because of this predictive analytics, personalized treatments also improved a lot, I would say. They are helping a lot. The predictive analytics or artificial intelligence helping doctors a lot for identifying the disease, or identifying, giving the precautions, or giving the medicines to the patients, I would say. Okay, and and they're managing. Okay, you guys know, like population is growing day by day here, and the doctors count is according to some survey, the number of like we have the scarcity of the doctors actually. So how we, even though we have that scarcity, how we are able to manage that one, here, because of this artificial intelligence, we were able to manage it actually. Okay, and we are able to identify that risk of the patients, or we are able to identify the chronic diseases like diabetes, or heart attacks, or I would say like BP, all the chronic diseases which we are currently, like world is facing, all the chronic diseases, the artificial intelligence is able to predict upfront, and giving warning to the people, I would say, so that they can take the precautions based on that one, based on that like warnings, I would say. And next one, and it avoids the human errors, of course. And as I mentioned, fraudulent transactions also we can avoid here because of this artificial intelligence or predictive analytics, I can say. And overall, I would say it has. I have a use case actually, which I'm going to discuss in a few minutes. So there I've explained actually how healthcare, one of the healthcare company reduced their saved actually the cost of their healthcare, uh, saved a lot of amount by applying these predictive analytics. I'll try to give that example as well. Okay. So these are all the different, yeah, these are all the different applications which I was mentioning actually here. Okay, now let's get into like a use cases which I was talking like a few minutes back. Okay, the first use case that I wanted to discuss today is readmissions. If doctor is not predicting, or if the doctor is not able to predict, if doctor is not analyzing the history of the patient or the lab reports, then if let's say he's giving the medicines just like that without a proper like analysis, then the likelihood of like rejoining or readmission of that customer or patient is more, I would say here. So because he did not prescribe the proper medicine, he did not give the proper medication to the patient. So likelihood of rejoining or readmission of the patient into the hospital is more. So because of this process, what happened, like slowly patients are getting rejoining or readmitting into the hospital. Because of that, healthcare companies are spending more amount or paying more amount to the hospital, like hospitals, I would say. So one of the healthcare company, they lost almost in one of the season almost $2 billion, I would say here. $2 billion. It's a huge amount, I would say here. If you convert in rupees, it's a huge amount. Okay. Then they started like analyzing what was happened, why is this happening actually here. Okay. Then they started a program called Hospital Readmission Reduction Program. Now, ultimately, they wanted to reduce these readmissions. Now they started introducing this predictive analytics in the hospital management, I would say. So how they are addressing this issue here, what they are capturing in the backend from the patient, okay, and how they are giving the data to the doctors, and how it is helping to the doctors for giving the proper medication to the patient. That's what I'm going to discuss now. Okay, first what they will do is they'll try to collect the data from like from every patient, whoever is enrolled with that like healthcare domain, I can say. Let's say I've enrolled, I took the policy in the Anthem, or I took the policy in the Bajaj Alliance, like that. We have different companies are there. So I'll try to take the health related records from that particular patient. I'll try to take the regular activities, like how he's performing, whether mentally or physically he's stable or not. I'll try to collect as much as data that I can from that patient. From that, I'll try to apply algorithms on top of that one. I'll try to make some predictions out of it. So I'll try to identify the risk of the patient here. Okay, so that makes me like that gives me more boosting, or I'll try to give that data to the doctors along with the doctor analysis. Then based on that data, maybe EHR is nothing but electronic health records. See here, whenever like this electronic health record also plays a crucial role here. What exactly mean by that one is, from the inception is nothing but whenever you started enrolling, whenever you started like hospitalized, like whenever first time you hospitalized, from that moment onwards, healthcare companies or government has to maintain that electronically that health records, so that I'll be having more data of that particular patient, so that I'll be having more predictions from particular disease, so that I'll be having more data related to the healthcare domain, so that I can make more predictions. I can make more intelligent solutions out of it, I can say. Okay, so in that way they started like actually predictive analytics, and like they're like improving like the example for this one is Unity Point Healthcare is one of the healthcare domain in the USA. As I mentioned, they lost almost $2 billion in one of the season, I can say. Okay, so what they have done is, with the help of this predictive analytics, they did not mention what analytics, I mean, how they implemented that analytics. They simply mentioned that, okay, we collected the data and we made like, we predicted something out of it. They did not mention what algorithm they've used and what they've like done ultimately, but like as per my research, actually, I got this information. So with the help of that, like predictive analytics, they could able to reduce almost 50% of the readmissions. So think like 50% of the readmissions is not a joke, for one healthcare company. That has actually created a revolution in the entire healthcare industry, I would say. Now they started expanding like the like same predictive analytics in the other like wings of their company, and they like making more money out of it, I would say. They're saving like lives of the like people also out of it. Indirectly they're saving their company's revenue, and there's as well as the like patient life as well, or people's life as well here. Okay, so that's what I wanted to say. So what is the key takeaway here? Who is the like, who is playing a key role here? Ultimately, a data is playing a key role here. Without data, I'm confidently saying that after COVID or post COVID, I would say, without data is running behind the, like I can say, the world is running behind the data, I would say. So without data, the world will not move. Okay. Generally, like some juniors or some of my relatives actually, they used to ask me actually, hey, I wanted to get into the IT industry. Like, what could be the better technology for us? Can you suggest me a good technology for us so that we can survive in next 10 years or 20 years? I like without second thought, I used to suggest them data is the like best industry nowadays, post COVID, I would say, because industry has identified the importance of the data. Industry started making the started tasting the data, I can say. Start tasting means like it started like having that fruits in their like own domain, I would say. Because of that, like they started like they're making more inventions, or they're spending more they're releasing more projects, or they're generating more jobs out of it, from out of their interest, I would say. Because of that, more jobs are getting generated here, like so that more people get recruited here. So I used to suggest in that way actually people here in the job industry, I would say. So the key here is data. That's what I wanted to say here. Okay, and the next one is, just a second. Next one is chronic diseases. You guys know like nowadays this BP, diabetes, heart attack has become a common diseases for in the world, I can say, in any country, I would say. Okay, so what is how like predictive analytics is actually giving benefit out of it, giving making that impact in the industry here. So what they are doing is, whatever the data that we are collecting from the patients or from the people, or whatever the data we are collecting through sensors of the I would say like watches, or the some wearable devices, I would say, like people who are wearing that devices, and they're collecting that data. From that, they're training that data, and they're able to predict that. Okay, of course, not only that data, they're taking the family history and their regular activities, and their like what I would say is like financial statuses, their mental state, their physical state, everything they're collecting here, whether he is stressable or not, whether he's facing any financial issue, job issue, or anything. every pinpoint they are collecting from the people, and they are able to predict that, okay, because of so and so conditions, because of so and so reasons, he may get diabetes, or because of the heredity, I would say, because of the family conditions, he may get the diabetes or BP in next 10 years or next 5 years. So they can able to predict that actually. So whenever you go to the doctor, with some small reason, based on this analysis, anyway, this the crystal ball is already available with the doctor. So all your data you're giving to the industry here, and doctor is able to make some decision out of it. And when you go to the doctor, then he can suggest you, hey boss. So these are all the reasons actually, like we are predicting in next 5 years you may get diabetes or sugar or heart attack, so and so reasons. You have to be very careful, or you have to do exercise from now onwards, or you have to be start following the diet, or you have to start exercising, like that. He will suggest something to the patients, I would say, or he will suggest something to the people, I would say here. So in that way, so they're able to predictive analytics able to uh, able to analyze the data and make the decisions, able to predict something out of it, and is helping indirectly the people's health as well, and saving a lot of lives, I would say here. That's what I was mentioning here. So here, not everyone, I mean, they don't need to alert everyone in the world, I would say. They will try to stratify in the sense, they will try to classify the people here. So here, classifying in the sense, high risk people, high risk, here we have different classifications. High risk, low risk, and medium risk is there. So they will try to concentrate people who are in the high risk category, I would say. And they will try to send a message, send messages, they'll try to give that precaution only to the people, that not entire world or whole world. They don't need to do that one as well. So they'll try to stratify that, or they'll try to identify that people, and they'll try to give that help them to settle their health actually here. So this is also one of the use case, I would say, how we can identify the diseases, chronic diseases, I would say. And the next one is, next use case that I've taken is Pfizer example here. So you guys know, a pandemic, how impact it has created after 2019. So I think Pfizer was the first company, I think, they announced the vaccination for the COVID-19. So after they announced in USA, we have a vaccine and we are going to release that vaccine, and that is going to relieve actually the COVID-19 or pandemic. Then they got huge demand from all the countries across the world, I would say. And how they're able to manage their inventory, how they're able to manage their supply chain, how they're able to manage their transportation, is purely based on this predictive analytics. So they started collecting the data from every country, okay, in which country the this outbreak is more, or the pandemic is more. Let's say India, the population is, since India population is more, okay, in so and so country, I have to supply more vaccination, or I have to supply more production. So in that way, they used to estimate, and they used to predict that, and they used to manage their logistics. They used to manage their production, I would say, based on the demand. Based on the demand, they used to produce the production, I would say here. Okay, so they were able to manage purely based on the predictive analytics that they implemented at that point of time, I would say here. So uh, even in the manufacturing industries also, AI is creating a lot of impacting to smoothen the process, I would say here. Okay. So this is about the applications of our use cases of the healthcare, I would say. Now I will try to walk through you one of the paper, or I would say um, like use case. I'll try to take one use case and I'll try to implement one of the algorithm, how we generally implement it in industry standpoint, or what is the general process we follow like while implementing these algorithms and all. So I have a paper here. Let me show you that one. Yeah. Yeah. So this is the paper actually which published last year by some of the people in the India. So heart disease detection using machine learning models based on different health conditions, based on health records of the patients, I would say. How we can save the lives of the people of this heart attack, I would say. Okay, you guys know like heart attack has become uh, pain in the neck nowadays in the every country, I can say, every country. So according to World Health Organization, right? So the death rates increased from 20.5 million, 20.5 million by 2021 when they compare with the 1990. So slowly the rates are increasing. Now we have to introduce our predictive analytics to save the lives of the people here. So how the machine learning algorithms are creating the impact here. So what are all these steps we have taken here and how we got the data here? That's what I was I'm going to explain here. So in order to understand this problem here, so in any machine learning process algorithm or in any machine learning process or any predictive analytics process, understanding of data is very important. Even in our real time also, we spend most of the time on understanding of the data instead of spending running the algorithms on top of data. We mostly understand the data first. We we make some conclusions out of it first, and after that we'll try to apply the algorithms out of it, and we'll make some we'll find out the accuracy out of the algorithm here. So for that, I've taken one data set here. The data set actually contains male, age, education, current, currently the person is smoker or not. So if he's a smoker, how many cigarettes he's smoking per day, and does he has BP, or does he has any prevalent, I mean, any heart stroke previously he got, or any diabetics he got, how much total cholesterol he has, how much BP he has, how much heart rate currently is having. So all these details I try to collect here. Currently, to understand, to analyze this particular problem, I've taken 4,000 records here to to make some conclusions out of it, I can say. And this is my actual prediction, and I'll try to compare the actual prediction and as well as how my machine learning algorithms are predicting, how my machine learning algorithms are matching my actual prediction. That's what my ultimate conclusion here. So that is what they have implemented in this paper here. So what they have done is they have taken the same data set which I've shown you just now, and they're running like different algorithms on top of the data. I'll show you how they're running that process. Like what all the different steps are there to follow to run that algorithms. Um, and they're applying different algorithms on top of the data, and they're finding out the accuracy out of it, and they're saving the lives of the people, I can say here. Okay, so what are all the different algorithms they used in this particular case study is, just a second. Yeah, so these are all the different algorithms. All these are supervised learning algorithms only, I can say. Supervised predictive analytics. These are all comes under supervised category, I can say. So decision tree algorithm, random forest algorithm, support vector machine, and the principal component analysis. Now, what I'm going to demonstrate to you guys is, I'll take like one basic algorithm, and I'll try to apply that basic algorithm on top of the data or data set that I've shown you just now. And I'll show you how we follow like real-time analytics, or how we calculate the precision, like how we predict the actual prediction that we already have, how we are meeting close to that actual prediction that we have. Of course, none of the algorithms meet 100% the actual predictions. Of course, at least very close to that actual predictions, at least. Okay. In any machine learning algorithm, machine learning algorithm, we follow these steps, irrespective of the, like I can say, data set, I would say. First, we'll collect the data, and we will try to identify what are all the features are there. Features are nothing but, in layman terminology, I would say, if you consider data set is nothing but a table. In a table is nothing but a two-dimensional data, which has rows and columns. Just a second. Oh, sorry. Just a second, guys. I'm sorry. Yeah. So if I talk in terms of layman terminology here, the data set is nothing but table, because run we run the machine learning algorithms only on top of the database data, I would say. We store the data ultimately in real time in the database only here, and we select the features out of it. Features are nothing but columns out of it. Okay. And we'll try to identify how many like missing values are there. I'll show you what exactly I mean by these missing values. And if any of the feature is not contributing in the prediction, then we'll try to delete them, or we'll try to delete that particular feature. And if any missing values are there, and we'll try to fill up those missing values, and we'll try to update the database ultimately. Of course, we follow that one regularly, and we'll try to we'll try to apply the logistic regression on top of that, which is a basic machine learning algorithm, I would say. Or we'll try to identify the distribution of different parameters or different features, and we'll try to decide which algorithm we need to apply. Okay, with different foldings, I would say. Foldings is nothing but number of iterations, I can say here. Okay. And why we apply different algorithms here is, we are not sure which algorithm is going to give the accurate prediction here. So with different data set, we need to test it regularly or thoroughly here, and we need to evaluate. We need to go with the majority voting here. I mean, whichever is giving the most relevant output for me, that one will consider it as a the accurate algorithm, I can say here. And finally, we'll predict. Finally, we'll make some conclusions out of it, I can say. So these are all the steps we follow. The same steps I have implemented practically here by taking one basic algorithm here. I'll just show you here. I'm just using completely using the Python here. My local Python I'm using. You can, if you want, you guys can use the Colab as well, which is generally we use that Colab only in the real time executions, I would say. So that it doesn't take any hardware resources of your personal computer, or like company computer, I would say. Mostly we use the cloud networking, I would say, cloud hardware, I would say here. So here, whatever the like flow, whatever the like flow chart I've explained, right? Everything I put here. First, I'm trying to gather the information from that one. Like I'll try to understand the features of the table or the data, I would say here, and and after that we are trying to load the data into the data frames, I would say. We call it as a data frames, I would say, in a real terminology. And we'll clean the data, because we may have the junk data in the data that we are trying to analyze, and we'll try to do two-dimensional analysis on top of that one, which we call it as a feature engineering. And technically we call it as a feature engineering. So also we can call it as a exploratory data analysis. So in multiple ways, multiple features, in multiple angles, we'll try to analyze the data. And after that, we normalize the data, and after that, we apply the modeling on top of that one, and we'll try to make some like precision out of it or accuracy of the like model we'll try to identify here. Let's get into that one here. You guys know, right? Like for implementing any of the artificial intelligence or predictive analytics, any thing related to the artificial intelligence, Python packages are like more useful here. The best example for that one is NumPy, Pandas, or the Scikit, Matplotlib, Seaborn, like that. Many algorithms are there here. So, sorry, many packages are there. We'll try to import the required packages here to analyze the data, to do the updates and the deletions. I actually use the Pandas here. To load the data, I use Pandas here. To analyze the data, actually, in a graphical representation, I'll go ahead and use actually the Matplotlib and the Seaborn here, I can say. Okay, and even scikit-learn as well, both. Okay, so first what I will do is, whatever the data I have here, which I've shown you in the Excel sheet here, I have a question here actually to everyone. So I do not see any string data in this particular data set here. You know why here? Why don't we have the string related data? Why do we have only numerical data in the data set? Any specific reason for that? Okay, I'll come back to this point here. So most of the statistical analysis we perform before we applying the machine learning algorithms on data is numerical data, not on the string data, string data of the data, I can say. So that is the reason why most of the algorithms, even in the real time as well, most of the time we'll try to, even if you have categorical data or even if you have string related data, will ultimately or eventually will try to convert that into numerical data, I would say, so that I can apply my statistical analysis on top of that one. That is the reason why I don't have here the string related one here. So example for that one is, I can take this particular column as gender and I can take the data here male, female here, but I did not take that way here. Why I did not take that way is, if I take the male and female, eventually I have to convert, like male is 1, female is 0, or female is 1, male is 0. I'll eventually have to convert that one. So that is the reason why the data set itself, I'm trying to maintain here numerical data so that I can apply all my statistical analysis on top of the data. Okay. That is one point actually where you're able to see all the numerical values in the data set, I would say. And next, okay, so how you load that data into the data frame is, we actually have pandas read.csv. Sometimes you may have the data in CSV, sometimes you may load the data from JSON files as well. Sometimes you may load the data from like different databases as well. So pandas has capability to read the data from any of these sources, I would say, and it can read the data from that particular source. And whether it is reading really or not from that particular source, we'll try to give actually head here. Head is nothing but top 5 records it will try to display here. That's what I was trying to, if you want, I can execute that one more time here. Yeah, so I've just executed that one. It has given me top 5 records from the data set here. It has loaded the data once again into the data frame. First data frame I have created here. So no worries, even if you run this one multiple times. I know I'm going a little deep into the technical. I'll not go much deep into this one. These are actually the data frames, and these are immutable. I can say data frames are immutable. Every time you create them, it is going to create the new data set, and backend it will be like a immutable kind of behavior, I would say. So I'm just reading the data here. I'm just trying to display the top 5 records here, whether it is really reading the data or not. I'm just cross-checking here. And after that, okay, I told you, like almost I have 4,200 records here, 4,210 records here. Whether my data frame is actually reading the entire data set or not, I can get that information using shape command in the data frame. Shape actually gives the data in the form of tuple, in the Python tuple, I can say. So Python, from that one, I'm trying to access actually the number of records and the features from it. Features are nothing but number of columns, I would say here. So here I have almost 16 columns are there here. 1, 2, 3, like that, like 16 columns are there. This is my target. All these are my input features, I can say. This is my target feature, I can say. So by using all these input features, I have to predict this one, target feature. These columns in machine learning terminology, we call it as a features here. So that's what I'm trying to mention here. So I'm just trying to read the number of record here. Features are 16 here. Total 16 fields are there here. Okay. And after that, I just wanted to know what data type it has considered while reading the data. So I did not mention any data type here. It is automatically inferring the data type here. I'm just like cross-checking that whether it is inferring the right data type or not. As you guys know here, we have numerical data here. It is simply displaying int4 and float data type only here. As I mentioned already, like we almost deal with the numerical data only here. So that is the reason why it is showing actually int 64, like float 64. So there is no feature related to the string, I would say, or varchar, I would say here in database terminology, I can say. Okay, so all these data types are correct here, and after that, I'm just trying to identify the null values here. This is most important step in analyzing the data actually. Even before we give the data to the like machine learning algorithms, we do a lot of analysis on the null values identifying here. Just I'm sorry, guys. Yeah. So I'm just trying to identify how many null values are there in each feature here. So what does it mean? What does it mean here is null value is nothing but nothing. See here, I'm just trying to take here for some of the values NA here. NA is nothing but it is not giving any information here. I can consider this as a null value here. Okay. See, any machine learning algorithm or any predictive analytics algorithms, whatever you're trying to train, they have to have maximum information in the data. Then only they can predict effectively whatever you're expecting from that particular algorithm, I would say. So that is the reason why we have to maintain as much data as we can. Almost we are not supposed to maintain any null values here. What if we have null values here? What we will do is we will try to, one second, guys, just a second. Just I'm sorry, guys. Yeah, I'm sorry. Yeah. I think we stopped it. Okay. So what if you have null values here? Like how we are going to manage that one is, if you still find, okay, maximum will try to maintain, will try to like wipe off this null values, I can say. If you still have those null values, we'll try to replace that null values with the mean median values. Mostly we'll try to replace that one with the median values only, which is an average of all the data set values that we have here. So that's what I'm trying to do here. I'm just trying to identify how many nulls are there in each feature, I would say here. So here, these many null values are there in each feature. So let's consider education is one of the feature. In that feature, we have 105 null values, not available values. I can say null values are nothing but like data is not available actually. And we have one of the feature called total cholesterol. There we have 50, what I would say, 50 null values are there. Okay, so better to replace all these null values either with the mean or median here. So for that, I'm just trying to identify how much percentage they are actually, how percentage of null values are there here. So I'm just trying to identify I'm just trying to calculate that particular one here, sum divided by that count into 100, so that you'll get the percentage of that null values on each feature, I would say. So hardly you'll be having 2% here. That is okay, but still I don't want to take any risk here. I wanted to replace these null values with the mean and mean and median values, I would say here. Before that one, I will just try to identify which are all the features actually contributing or predicting the actual outcome here. Which are all the features are majorly contributing to predict my actual outcomes here. That's what I wanted to identify here. For identifying that one, I have to use actually the correlation. For that one, I have to generate the heat map. So what this heat map will do is, it will try to generate the relation between the variables or relation among the variables are features that you are trying to deal here. Here, let's consider here. Okay, so heat maps generates actually negative values and positive values. Mostly we will try to consider actually positive values here. We may have 0, we may have negative values, we may have positive values also here. So what does it mean? What if you have the positive value here? So once if okay, let's consider cigarettes per day is actually having more positive value for the cigarette smoker. That means what exactly mean by this one is, these two variables are linearly related here. That means cigarette smoker is he's smoking more cigarettes per day. That's what it is trying to give here. That's what the information it is trying to give here. Okay, so how they're linearly related, each variable with other, that's what I wanted to identify here. So for that, I have to generate the I have to identify the heat map. I have to generate the heat map here. Okay, so all the positive values I'll try to identify here. Okay, so which are all the features are having that positive values, I'm just trying to identify here. These are all the features I'm going to use in my predictive analytics. Rest of the features I can consider, I may consider, I may not consider here. But these features actually contribute, like places a crucial role in identifying that analytics, identifying that predictive analytics, I can say, outcomes, I can say. Okay. So as I mentioned, right, we have to replace that null values with the mean or median. For this data set, I would say median is the sometimes based on the use case, we can replace with the mean values as well. That depends on the use case we will go. For this data set, I feel that median is the correct value, I would say. So I'm trying to replace, since my outcome parameters are outcome deciding parameters are these parameters here. For all these parameters I'm considering here, I'm trying to transform or I'm trying to replace that null values with the median values that we have currently. Okay, and after that, okay, once you replace that median value here, we are once again I'm just trying to calculate that null values here. Currently the null values are 0 here. Previously we got some percentile, right? At least we got here 2.47, 0.68 or something, some percentage we got. Now after replacing that null values with the median, now we got everything as 0 here. So this is very important step in while implementing any machine learning algorithm, I would say. Okay, and after that we need to take the statistical values of each and every feature, I would say here. So what we are going to get from this one, from the statistical analysis of each feature is, let's consider in my analysis, what is that maximum age people are actually falling under 25%. Okay, falling under uh, min and max. What is that age group actually I'm trying to do analysis here? Like minimum age group is 32, maximum age group I would say 70 here. That means I'm trying to do analysis on between these two age groups. So I'll come to know the minimum and maximum values are mean and medium values of each and every feature of the feature that we are trying to use for the analysis purpose, so that I can make some conclusions out of it here. See, here I started doing the EDA here. I'm still analyzing the data here. I'm still trying to make some my own conclusions here, I can say. After that, I'll try to train based on that conclusions, I'll try to train my algorithm here. So here, like I can make some conclusions here. Like minimum age is 32 and maximum age group is age is actually 70. Of course, like after some time, I'll try to again divide this age group into different categories again. Middle age, young age, or adult age, young age, or middle age, or old age, like that, I can divide this one again. Okay. So, and after that, remaining like features also I'm considering here, because these features actually decides my, is going to create more impact on my output. That is the reason I'm considering only these out of 16, only these things I'm trying to consider at this point of time. Okay. And after that, one by one feature I started analyzing here. Okay, first we are trying to analyze the outcome or prediction, whatever like we are like thinking. Okay, so my prediction actual values are actually here. CHT is nothing but here heart disease, one of the heart disease name I can say. um, like in next 10 years they may get heart disease or not. Okay, chronic vascular like heart disease name is there. So that's what I wanted to predict here in next 10 years, whether a person can get that heart disease in next 10 years or not. That's what I'm trying to predict here. So based on my theoretical analysis, I can say that, okay, this person will not get actually like the heart disease in next 10 years. But if I give the same data to my machine, how it is going to predict whether this person is going to get heart disease or not? How it is actually calculating that one in the back end? That's what I wanted to consider here. So for that, what I'm trying to do here is, as per my last column, that is 10-year CHT, I'm trying to do some basic analysis. How many negative values are, how many positive values are there here? Negative values are nothing but these many people will not get that too in the female category and male category. These many people will not get actually heart disease. Female category, I can say. Under male category, these many percentage, I would say, are people are number of samples, I would say here, number of patients, I would say here. So these many patients will not get a chance of heart attack. They'll not get a heart attack in next 10 years. This is my actual prediction. Okay, I've done the basic analysis on the target feature, I can say. Now I started doing the analysis on the input features, whatever I'm trying to take give input as my machine learning algorithm. So for that, before I go ahead and do that one, I have to analyze actually how each value is distributed. This is also one of the important step in calculating the machine learning algorithm. In any of the algorithm, we actually implement this one. So for that, each feature, whatever I considered previously, I'm just trying to take that one here. I'm just plotting and trying to understand here. The values are spread across the like broad values, or like values are like within the specific range only, or do they have a spike in the within a specific range? Are they distributed equally with different ranges? That I have to do that analysis here. So so that I can make some conclusions here. Okay, so that's what I've done here. If you observe here from all these like graphs, this one and this one and this one actually has peaks here. So as per the Gaussian distribution, the value should not have any peak values like this. The value should not have any peaks like this. The value should distribute at least like this. So that is the reason why what I will do is I'll try to like okay, I'll just have an analysis in mind here. Okay, the values are not equally distributed here. The values are have right skewed here or left skewed, or like equally distributed. If they are equally distributed, I would say that okay, normal distribution or Gaussian distribution. So if they are not equally distribution, if they are like following right skew or left skew, then I can say that okay, these values are having that left skew, they're following left skew or right skew here. Okay. So, and on top of that one, I'm just trying to consider the age as well, because my point is here, my ultimate target is here, based as the age is growing here, will they get heart disease? That's what I wanted to like identify here. For that, I'm trying to do basic analysis on the age also here. What is that age distribution here? So what range we have here? So as I mentioned, minimum range we have taken 32, and maximum range that we have taken is 72 here. That's what I'm trying to see. Pictorial representation, I would say. Whatever we understood in calculation, same thing we are trying to understand in a pictorial representation here. Okay. Okay. See here. Uh, the age is having actually our age or the heart rate is having broad values here. Or I can say here also, if I see 200 to 400, total cholesterol also is having actually broad values, I can say. So if you have more number of values, or if you have, in technical terms, we call it as a outliers. So if you have that kind of values, we have to encode them. So in real time, we call it as a labeling actually. So we are trying to reduce the number of values distribution here so that I can identify the outcomes efficiently or effectively, I would say. So for that, I've written a couple of encoding functions here, and I'm trying to on heart rate and the age, I'm trying to distribute the data. I'm trying to reduce the number of values here because they are broader here, I can say. Range is broad here. That is the reason I'm trying to reduce the values here. So how I'm trying to do that one is age. If it is less than 40, I'm just considering the category as adults. If the if age is greater than 40 and less than 55, I'm just trying to consider as a middle values. If age is above 55, I'm simply considering as a senior here. So because less the number of values, more the more effective or efficiently we can make the predictions here. So that is the reason I'm trying to follow the labeling here. And after that, heart rate also, as I mentioned, right? It also has like broader values. So for that, I'm just trying to like encode here, or I can say create the labels here out of it. So that's what I'm trying to do here, and I'm doing the basic analysis out of it. Okay. So after that, two-dimension analysis also I'm doing here. Two-dimension analysis is nothing but if age is growing, how the BP is actually behaving, how the diabetes is actually behaving. Is it increasing, linearly increasing, or do they have relation or not? So that's what I'm trying to maintain, or that's what I'm trying to check here. Okay. And after that, that analysis I'm trying to keep on continuing here with respect to different features, I would say here. And now I'll try to come to your last point. Last point is nothing but I'll try to come to a conclusion of EDA here. Okay, I've done the two-dimension analysis in all the prospectives, I can say. Okay, now I got my own I got my own understanding of the data, and after that, I'm trying to like two-dimension analysis here. Now I'm trying to give this data to the. It's time to give that data to the algorithms. Now for that, before I go ahead and apply the data to the give that data to the machine learning algorithm, I have to apply the logarithm on each category values or each feature, I would say, whatever like I'm considering here. So for that, I'm just applying the log values on each feature. Log values are nothing but here, I have considered here standard scalar. the standard scalar log values will vary from -1 to 1. So when I apply that one, that is the reason why I got some negative values and the positive values also here. Of course, some values I got more than one also here. Mostly the values are distributed between -1 to 1 here. And I'm just trying to import the, as I mentioned here, I'm just for understanding purpose or just for demonstration purpose, I'm just trying to take here the linear regression algorithm here. So before I go and like decide that one, before I go and give that data to the linear regression, I have to prepare the I have to prepare my data set here. So here in technical terminology, I have two data sets are there. One is training data set and second one is the test data set here. Whatever so far I'm explaining, all these are part of the article discussion only, guys, here. Okay, I'll correlate all this discussion with the the article, whatever I was showing some time back. Okay, same steps, whatever they implemented in the article, all these steps I'm trying to re-implement here. I'm just trying to show you or demonstrate you here how generally algorithms are getting implemented in real time. Okay, so I have to prepare the training data set and the test data set here. Training data set is nothing but the data set which we actually give it to the algorithm. Testing data set is nothing but we have to give that data set to the, based on the training, how your if you give this test data set to the algorithm, how it is going to predict. So that we call it as a test data set here. So both we have to decide here. Here I'm considering generally, even in the real time as well, even in the industry as well, we consider 80-20 or 75-25 ratio here. 25% of the 25% of the data we consider as a test data set. 75% of or 80% of the data we give it to the we give it for the training purpose. Now I prepared for that one here. That's what I'm trying to do here. Okay. And after that, logistic regression algorithm, I'm just importing that one. I'm just applying my data here. So I created the training data set here, X train, Y train, and X test, Y test. From this one, I'm just applying, I'm just giving that training data set as an input to my algorithm. And after that, I'm just asking it to predict based on my test data here. And it is giving actually here this kind of data set. Okay, and we got trapped here. Why I say it's a trap? While consider, this is actually the accuracy score that it has generated out of this one. So whenever you make some conclusion here, you need to consider two things here. One is accuracy score and second one is the cross validation score here. Cross validation score is nothing but, accuracy score is nothing but based on the test data, how it is actually predicting. Cross validation score is nothing but, okay, we understood that 25% of the data set we are giving it to the model, but it doesn't know which 25% of the data it has to consider. So for that, since it doesn't understand which one it has to consider, uh, we are telling that I mentioned already like a k-fold, right? And the k-fold is nothing but number of iterations you will try to CV equal to 5 is nothing but 5 times I'm asking my model to iterate that algorithm, iterate that algorithm and take that mean of that one and try to compare with the accuracy score and the cross validation score. If both are matching, then I would say that okay, they're close at least. Okay, and I'm okay with this accuracy score and the cross validation score. But if you observe here, recall is nothing but how it actually predicting the, okay. Before I go ahead and explain this one, I have to explain about the confusion matrix here. Confusion matrix is nothing but, consider this is your prediction values. Consider this is your generated values actually. Okay, or your data set, I would say. So one is nothing but positive. I mean, true positive. We call it as a true positive. One uh, uh, one 1 0 is nothing but true negative, I would say. 0, 1 is nothing but false negative. 1, 0, again 1, 1 is nothing but true positive. So like that, we will be algorithm will try to generate this confusion matrix, which is very important for making the like a conclusion here. So in this analysis, this is not generating accurate values for the positive test cases and the negative test cases here. So it is more giving favor to the positive test cases only, not to the negative test cases here, which is a trap, I could say. So if these two are equally distributing here, even if you get this particular accuracy, if they are almost equal here, then I would say that my machine learning algorithm has performed very well here. Since this is not giving here right values, I would say that my accuracy is not correct here. Then I will apply some like a few more I'll try to I can say that this is imbalanced data here. Then on top of that one, I'll try to balance the data, and I'll apply one more time that algorithm here, and I'll try to make conclusions out of it again here. Now this time here, it has generated almost 65 and 67% of the accuracy here, I would say. And if you observe the recall values are nothing but how how it is actually predicting the actual values, the true positive values, I can say. So some mathematical calculations are there in the back end. Anyway, since we are running out of time here, like I'm not explaining that one, but back end, it actually takes the calculations completely. Statistical analysis it will try to perform here. Since these two values are close to each other here, and they're like seems very close here, I can say that okay, my algorithm is somewhat it is giving correct predictions here. So I can say that 65% it is predicting correctly. That's what I can make here. So similar way, this paper is actually applying the same data set on multiple, sorry, just a second, multiple algorithms. They're just trying to use multiple algorithms here, and they're predicting, then they're just making conclusions out of it here. Just a second, I'll show you that one. Yeah, so this is the conclusion out. This is the confusion matrix for each and every algorithm, I would say. So this is for the random forest, this is for the decision tree, this is for the PCA, this is for the gradient boosting. All these algorithms are applied on the data set here. Ultimately, out of all these algorithms, which one has given more accuracy here, more precision and accuracy here? So out of all those things, random forest actually has given me more accuracy or more percentage here. So I can say that okay, I'll follow for this particular data set for this kind of predictions. I'll go with the random forest one. So that's what they have given conclusion in the paper here. Random forest is the giving the best results here. So this is the case study of the art detection here. Yeah, so that's all from my end. Any questions?
Thank you, sir. Dear participants, if you have any queries, you can post in the chat box. Sir will clarify your doubts.
Or I can share my email ID. You can share the details to my email ID as well.
Okay,
Post this session. I think I'm taking others' time. Yeah, if no questions, I think we can stop here.
Thank you, sir. We are truly grateful to you, sir, for gracing this occasion with your presence and enhancing our understanding with your practical knowledge. We would like to hear more from you in the future, sir.
Definitely.
Thank you so
Definitely.
much, sir. Thank you.
Thank you all.